Hello, welcome to today's lecture. We're going to continue our Math 1B. We're starting chapter 6. We're going to talk about the area and volume and the techniques of integrations, how to calculate area and volume. There you go. 6.1. Page 1. In page 1, we have the definition of area between two functions. So how do we in general define area of an object or something? So suppose you have x-axis and you have y-axis. Suppose you have this rectangular object here. It's bounded between 0 and A on x-axis, and on y-axis, it's bounded between 0 and B. Okay, you say that in algebra, I learned that the area is equal to this measurement here, whatever it is. If you calculate that 0 to A, the length is equal to A times this measurement here, the length 0 to B, which is just B, A times B. In calculus, you say that, okay, very well. This line here, this line, straight line, flat line is line y or f of x equals to b. F of x is equal to b. This is the definition of a constant function or flat line. And my x ranges between 0 to a. So x is in between 0 to a. Very well. We learned about the integral. This area here is nothing but the integral x ranges between 0 to a of function f of x with respect to x. So when you have one function, f of x, and you're finding the area between f and x-axis. Guys, remember that x-axis has definition y equal to 0. X-axis or y equal to 0 are the same thing. When you're talking about line y equal to 0, it's equivalent saying that I have my x-axis, just x values. So the area is the integral of function f while x ranges between 0 to a. I expect you to ask, what if I have a different function down here? What if I'm looking for the area between these two functions? Take a look at this. Suppose on top you have function f of x, and down here you have function g of x. Instead of the function bounded between the area bounded between two functions, f of x and y equal to 0, here you have f of x on top, and down here, the lower bound is function g of x. And you're looking at the area of the region bounded between these two functions. Again, x ranges between 0 to a, for example, and this is your region. You're looking for this area. What is this area? So in this case, in more general case, the area of the region bounded between f and g, the top function is f of x. So you get integral of f of x minus g of x with respect to x. And your x ranges between 0 to a. Well, in general, we say that when it comes to the area, suppose your x is bounded between a and b. So let's write the official definition. Let x be bounded between a and b, and function f, function g are continuous, and functions f of x and g of x are continuous functions, nice functions on closed interval a and b. This is closed interval. And let f of x be greater than g of x. Let f of x be greater than or equals to g of x. Then the area of the region bounded between f of x and g of x on a and b is defined this way. Area is equal to integral a to b f of x minus g of x dx. Let me write a quick note for you. Note. If you are not sure f of x is greater than equals to g of x, or g of x is greater than equals to f of x, then area is equal to absolute value of the integral a to b f of x minus g of x dx. So if you're not sure which function is greater than the other one, and you're finding the area, you can calculate the whole thing and eventually put them inside absolute value to make sure you have a positive number when it comes to area. Very well. We are still on page 1 of the notes. Example. So here in this example, what do we have? It says find the area. Okay, we're looking for the area of the region bounded. So we have a region bounded above by function y equals to e to the x, bounded below by function y equals to x, and x is in between 0 and 1. Bounded above by e to the x, bounded below by y equals to x, and x ranges between 0 to 1. There you go. So let us practice that quickly, see what's going on, what are we looking for. This is your x-axis. This is your y-axis. Okay, y equals to e to the x is an exponential function. Your exponential function goes like this. Y equals to e to the x. Then you have a line y equals to x. So let's practice together. Y equals to x. This is y equals to x. Very well. We're looking for this area. The area bounded between 0 to 1. So this is the area between the graphs of these two functions. This little piece here is the area that we're looking for. What is this area? We just learned that to find the area, this is equal to the integral. X is bounded between 0 and 1, so my A is equal to 0, and my B is equal to 1. 0 to 1. Up top function minus lower function. My top function is e to the x. So e to the x, the top function, minus the lower function here, y equals to x. The lower function, y equals to x. So e to the x minus x, bottom function, with respect to variable x. So this is the setup for our integral. Okay, this is our setup. Now we're going to find this area. Very well, okay. Let us calculate each of these and then find the area. So you have the integral of e to the x. Remember that the integral of e to the x is e to the x plus c. The integral of x dx is a half x squared plus c. Very well. And remember that we mentioned when we talk about definite integral, integral that has lower bound, has upper bound, you don't have to add the constants of integration. So the integral of e to the x is e to the x. We have subtraction. The integral of x is a half x squared, and x ranges between 0 to 1. 0 to 1. Well, first we plug in 1, then we plug in 0. You get e to the first power minus a half 1 squared minus Then you plug in 0, e to the 0 minus a half times 0 squared. Very well. I get e to the first power, e to the first, minus a half, e raised to 0 is equal to 1, minus 1, and this guy is just 0. So I get e to the first power minus 3 halves. E to the first is just e, so the area is e minus 3 over 2. Let's go over another example. We are on page 2. We are working with more interesting examples. On page 2, example. So this example says, find the area between these two functions, y equals to x squared and y equals to 2x minus x squared. Okay. What do we have here? We only have two functions. We know that the area follows this formula. The integral a to b f of x minus g of x dx. I expect you to ask, okay, what is a? What is b? I don't have a and b here. What is a? What is b? So note that, in general, note. When a and b, lower limit and upper limit, are not given, we need to set the functions equal to each other and solve for the variable. As you can see, you only have two functions and you don't have the lower limit, upper limit, what is a, what is b. You have to take these two functions, set them equal to each other, and solve for the variable. Okay, let us do that. X squared is equal to 2x minus x squared. Let us add x squared to both sides. We get 2x squared equals to 2x. Let us subtract 2x. We get 2x squared minus 2x equal to 0. Now factor out 2x, x minus 1 equal to 0. By solving these two, we get x equal to 0 and x minus 1 equal to 0, or x equals to 1. When a and b are not given, we need to set the functions equal to each other and solve for the variable. We took these two functions, set them equal to each other, and solve for the variables. Here you have two solutions. One of them is 0, The other one is 1, so A, the lower limit is 0, and B, the upper limit is equal to 1. Very well. Now that we know that the lower limit is 0 and upper limit is equal to 1, we can use the area formula and actually find this area. Okay, so which function is f? Which function is y? Let's take a look at the graph of the function. Graph of the function. You can use Desmos. You can use GeoGebra. I myself prefer to graph them and remember how to graph these functions. For example, y equals to x squared. I know the graph is a parabola opens upward. I know that. I learned it in algebra. I practiced that in pre-calculus. So I know that this is function x squared. This is this function here. My second function is 2x minus x squared. Okay, since I have exponent 2, the degree is equal to 2, for sure I get a parabola. But since I have a negative leading coefficient, it's not convex, it's concave. It opens downward. So what I'm going to do, I'm going to plug in a couple of points. I know in general this is a function that opens downward. If I plug in 0, 0 minus 0 is equal to 0. So it passes through the origin. This is this function so far, 0 and 0. And I know that my upper limit is 1. So if I plug in 1 here, I get 2 times 1 minus 1, 2 minus 1, which is 1. So at 1, my function, at 1, this function is equal to 1 here. Okay, and at the same time, I know that this function opens downward. Very well. So if I connect these, I get the general idea of the behavior of the graph of the function, which is x squared, this is my x squared, 2x minus x. Okay, and the region is just here. I'm looking for this area between these two functions. So what's the upper function? The upper function is 2x minus x squared. This function here, 2x minus x squared. And my lower function, the blue function, is just x squared. So this is my f, and this is my g. So the area is equal to integral 0 to 1 f of x, the top function, 2x minus x squared, minus the lower function, x squared, so let me use a different color for you, minus x squared, dx, with respect to variable x. So this is equal to the integral 0 to 1. Let us combine our terms. We get 2x minus 2x squared dx. Okay, now we just take the integral. The integral of 2x is 2x squared divided by 2 minus the integral of x squared is x cubed divided by 3. So you get 2x cubed divided by 3. And since we have definite integral, we don't need constant of integration. It is 0. you can cancel out 2 and 2. This is equal to. If I plug in 1, I get 1 minus, then I plug in 1, I get 2/3. And don't worry about 0. Why is that? Because this guy has x in it, this guy has x in it. If you plug in 0, the outcome is 0, so we're not worried about 0. Forget about 0. So you have 3/3 minus 2/3, which is 1/3. This is your area. Another example, including trig functions. We are on page 2 still. So question says, find the area bounded between two functions, y equals to sine x, y equals to cosine x, and x ranges between 0 and pi/2. Okay, perfect. So in this case, 0 is your lower limit, and pi/2 is your upper limit. So far, I know that I have my A and I have my B. Very well. Okay. I know that the area follows the formula integral a to b f of x minus g of x dx. Guys, when it comes to trig functions, always graph them. You'd be surprised when you see the behavior of these functions. Very well. Sine function, cosine function, on x-axis, I know these functions just oscillating, continuing, y-axis. Okay. Let us start by graphing sine function. Sine function, some part of sine function on the right-hand side. So here it starts at 0 and 0, and it stops at 2 pi. Let's move this 2 pi a little bit here. This is your pi. This is your 2 pi. And this is the graph of function. This is your sine function. Sine x. Okay, what about cosine? Remember that cosine function is 0 at pi/2 and 3 pi/2. And the graph is like this. Some part of the graph is here, and some other parts is going this way. So this black function is your cosine function, and this blue function is your sine function. Cosine x. Okay. X ranges between 0 and pi/2. 0 and pi/2. Let me regraph this little portion for you here so you see what's going on. Zero to pi/2. So my cosine this is my sine, let me just use the color for you. X-axis. This is your cosine function. This is pi over. And my sine function, it just continues this way. This is my sine function. So again, this is the general behavior of sine and cosine. And this guy, this little piece is this piece projected here. So you can actually see the intersection between these two graphs, which function is on top, which function is down. Okay. Well, what do you see here? Between 0 and pi over 2, 0 and pi over 2. On the left-hand side, your function cosine is up, your function sine is down, but after this intersection, after this point, sine is up, then cosine is down. So one area is here, 0 to pi over 4, and the other part of the area is located here, sine, cosine, pi over 4 to pi over 2. So let us write a little note for you here. Note. Note. After graphing these two functions on 0 to pi over 2, we have two areas. So your area, total area, is equal to one area plus the second area. Area on the left-hand side, area on the right-hand side. Very well. On the left-hand side, your A is 0 and it stops at pi over 4. 0 to pi over 4. Which function is on top? Cosine function is on top. You get cosine x minus sine x dx. On the other side, you range between pi over 4 and pi over 2, pi over 4 and pi over 2. Which function is on top? Sine is top, in top, sine x. Which function is down? Cosine is down. So minus cosine x dx. Very well. Let us calculate each of these. Then find the area. The integral of cosine is sine. So you have sine x. The integral of sine is minus cosine. Minus gives you plus. X ranges between 0 to pi over 4. Plus, the integral of sine is minus cosine, and the integral of cosine is sine. Remember that you have a subtraction next to it. And your x ranges between pi over 4 to pi over 2. The rest is just plug them in and simplify algebra. So sine of pi over 4 is square root of 2 divided by 2 plus. Cosine of pi over 4 is square root of 2 divided by 2. Sine of 0 is 0 and cosine of 0 is 1 plus. Cosine of pi over 2 is 0. Minus sine of pi over 2 is 1. Minus cosine of pi over 4, it has a negative sign next to it, negative square root of 2 over 2 minus sine of pi over 4 is square root of 2 divided by 2. Perfect. So here you have 2 square root of 2 over 2 minus 1 plus negative 1. You distribute the minus sign here, we get positive 2 square root of 2 divided by 2. You can simplify 2 and 2, 2 and 2, square root of 2 plus square root of 2, 2 square root of 2, so you get 2 square root of 2 minus 1 minus 1 minus 2. Okay, let us move on to page 3. Page 3, the last example. Question says find the area enclosed between y equals to x minus 1 and y squared equals to 2x plus 6. Okay, perfect. You have two functions, y equals to x minus 1. We all know that this is just a line, a linear function. Linear. This place y squared equals to 2x plus